This is part three of the same series of simplifying radical and exponential expressions. I'm gonna link the first two in the description if you're interested to find it to see it. Okay, so all right, so the first one here, I think we have done this on the second video. Then let's do this one right here. Okay, so we don't really have radicals here; they're already in exponential form. Okay, so in this case, let's do a little bit of review. Okay, so if you have x to the 1/2 plus, not plus, but times, so basically you're multiplying times x to the 3/2. Since you are multiplying and they are of the same base, then you can just pretty much add the exponents. Okay, so that's that. Okay. Now, however, if you have, so that's the basic idea. If you have the same basis and you're multiplying, you add the exponent. However, when you're dividing x to the power of 5/2 divided by x to the power of 1/3, well, you're dividing and their bases are still the same, then you just copy the base and then subtract the exponents. So that's the general idea. Now, how about if you have something like this in the problem? Well, everything in the numerator, basically, they have a positive. Basically, you add their exponents, and the one in the denominator you sort of subtract. So what do I mean by that? So in this case, you have two expressions that are in the exponents. Well, not really expressions, but factors that are in the exponents. So you have x to the power of. You're multiplying that, so that will be 2/3 plus 1/4 because they're multiplying and they're both in the in the numerator. But this one right here also have the x as a base, meaning all three have the same basis. Then therefore you can just subtract that exponent. Okay, so that's the general concept there. Now, what about if you have something like well, now let's complete this one first. So now you have I'm gonna do the operation on the exponents here. 2/3 plus 1/4 minus 2/5. So therefore your greatest common factor is going to be 30, no, 60. Yeah, so that's gonna be 60, which is kind of, yes, there's really nothing slower. Okay, so 60. So therefore the first one you have to multiply the first one with, to make it 60, 20/20. The second one you need to multiply by 15/15, and then the last one 12/12. 12/12. Ah, okay, so just my 12 doesn't really look like 12. All right. So now, so 20 times 2, that's going to be 40. 1 times, is it 1/4? Yeah, 1 times 15 is 15. And then 2 times 12 is 24. And so we simplify that. 40 plus 15 is 55 minus 24, that's 26 plus 5, 31. Negative, yeah, I think that's 31/60. Well, we can't really simplify that, so that's it. So this one becomes x to the power of 31/60. So this is your final answer. Now, just in case you want to change this into a radical, this is the final answer in exponential form. But if you want to change that into radical form, then you just copy x to the power of 31, which is the numerator, and then in your index will be 60. So these two are both simplified answer depending on the what form. Excuse me, depending on what form you'd like it to show. All right, so next one. Okay, well, you have on the next one, you have two factors in the numerator and then also two factors in the denominator. So every one that, as long, assuming they have all the same basis, okay, all the exponent of the factors in the numerator are getting added, and everything that are in the denominator are getting subtracted. But you need to be careful here because the second one has a negative exponent, so that means you're subtracting a negative exponent. Okay, all right, so let's rewrite this. So this is going to be x to the power of 1/3, the first one, plus 4/3, the second one, minus 2/5, which is the first in the denominator, and then minus -1/3. So you need to be very careful with that. Okay, so now you have, let's simplify the one that we can simplify. So this is going to be x to the power of 1 plus 4. That's going to be 4 fifths minus 2. Oh, why did I say? Okay, whoops. Uh, 1/3 plus 4 thirds is going to be 5 over 3 minus 2 fifths. And then the minus becomes a positive, right? Okay, now we can simplify some more. X to the power of 1/6 plus 1/3. That's going to be 6 over 3 minus 2 fifths. And now we can subtract the 6 thirds minus 2 fifths. 2 fifths, their common denominator is 15 minus 15 in here. So that's, you need to multiply this one by 5 over 5. You need to multiply this one by 3 over 3. So that's gonna be 30. And then 2 times 6, 2 times 3 is 6. So 30 minus 6 is 24 over 15. Let's simplify this. You can divide them by 3. So 8 over 5. So therefore, this is x to the power of 8 over 5. Again, this is the simplified version in exponential form, but if you want it in a radical form, you can make it x to the 5 over 5 plus 3 over 5. And so this one becomes 1, so x stays out. And then this one right here, x to the 3, and then fifth root. Now this, converting this answer into this format is in radical form. This is in our first two videos. Okay, that's discussed in the first two videos. Okay, last problem. Okay. I suggest that every single problem that I do, that you pause after it and retry it in your own. See if you can do it, and double check your work. Okay. All right, so now again, this one has some number of ways to do it. You can either raise each one to the exponent or solve this one first and then raise. It does not matter as long as you're doing your solution correctly. What I'm gonna do is I'm gonna follow PEMDAS and gonna do the parentheses first. So since this is a division and they have the same basis, so therefore I need to subtract the exponents. So that's gonna be 1/3 minus 2 fifths, right? All right, and all of that will be raised to the power of 1/4. And so now I'm gonna do the fraction subtraction here. The common denominator is 15. Okay, so I'm going to need to divide this one by 5 over 5 and this one by 3 over 3. So this is 5 and that's going to be 6. So therefore, this is going to be negative 1/15. All right, so this becomes x to the power of negative 1/15. So basically, I did the subtraction on the side to the power of 1/4. And so now, since when you're raising an exponential to another exponent, then you can multiply the exponent. So this becomes x to the power of negative 1 over negative, oh, I don't know what's going on. All right, x to the power of negative 1 over 60. Okay, now sometimes, so this is in itself an answer, but sometimes they don't want you to have a negative exponent. So in that case, you can rewrite it as 1 over x to the power of 1 over 60. That is to move, if it's a numerator, you move it in the denominator and becomes it gets the positive version of that exponent. So this can be an answer, and again, you can convert it into a radical if you want to. There are so many levels of simplifying, so it depends on how far your teacher wants you to go and what is the specific instruction. In this case, I'm gonna stop here. This is the simplified exponential expression for that particular problem. All right.